Hello, my friends. Welcome back once again. We are looking to enhance the Metro Map project from the WiByte Python curriculum available at www.wibyte.in. In the previous video, we saw how we could use some pretty interesting logic to make these lines have turns. For example, my scratch line, notice, goes inclined and then becomes flat. My Python line has even more turns. But this gives rise to another problem which we need to solve, which is, as you notice here, the labels of the lines, labels of the stations are in fact now going on top of the stations. Now, taking this a bit more generally, in fact, it is really nice if we could somehow make the label offsets also flexible, because right now what's happening is that the fixed label offset is being applied for the entire for every station, which is why notice on the scratch line every label is below the station. On the Python line, every label is on the right side of the station. But it will be really nice if we could make this also flexible, because then we can sort of have full control on this, and it turns out that we can give this flexibility to the labels just like we have given the turns on the line. Let's see how this works. So let's start with an example so that becomes clear. Let's say once again I look at this network which has one turn. Now remember, the way I achieved this was saying that, okay, look, I'll introduce a new list here, step, say, change station index, and the idea was that basically this stores all the stations, all those indices where the step changes. So it was 0 and 3 because from 0 till until 2 the step was 070. From 3 onwards it was 70. We looked at this in detail in the last video. Now here I'm going to do the same thing. Let's say I want the station offset, the label offset to be minus 30 for the first four stations. That's why my label is appearing, let's say, on the left side. But for station number 4 and 5, I want it to be, let's say, 0 and 20 on the y direction. So what I'm going to do, basically analogous to this, I'm going to create one LO change index. In this case, it will be 0 and 4. What I'm trying to tell is that, okay, look, the label offset is going to stay from 0, 1, 2, 3 the same. At 4, there'll be a new value and this will be the value. Exactly same logic. We just have to make the same changes, but for the label offset. So if I look at the changes that are needed, well, like I said, the label offset will now become a list of lists, just like step became a list of lists. Exactly same. There will be one more list created, which is LO change index. And what I mean by that is analogous to step change index. Where does the LO offset change at which station? Now, once I pass these inputs in, once again, I'm going to extract both the index and the station, just like I was doing for the steps. And now I need a bit of a logic to determine the label offset for every station. Once again, you can see that this is exactly the same as figuring out the step for every station, almost exactly the same. So what I do is that I create a couple of variables. I call it, let's say, LOCHN. Now this is analogous to channel index, sorry, change index. Basically the index of the station where the label offset will change. I set a counter variable to 000, call it MMM. Now once again, I iterate through the entire list. Remember, this enumerate will give me index as well as name. This IDX will go from 0, 1, 2, 3, 4, and so on. If I see that my IDX has become same as LOCHN, uh, I will take the next LO to be label offset MMM, which is basically reading off from the label offset, which is now a list of lists. Exactly again, same as what I did for step. And now when next time this condition happens, because remember IDX is increasing, next time this condition happens, well, I will look at the next value of label offset. Just like before, I need to update the LO change. I can do that by looking at the list LO change index. I can either go to the next item, or if the list is already over, which means, let's say, for example, in this case, I'm already at 4, then there's nowhere else to go. So I say, okay, no problem. I will set to a very large number. In fact, exactly the same logic as earlier. So as I sort of traverse through this loop, index keeps increasing and I keep getting the right label offset for every. Let's see this in code because that makes it more clear. So I come here to my function, which I had written previously. Now remember, I want to make it flexible with respect to the labels. So what I will do is that I will say, okay, let me make my label offset. I will make a list of lists. So let this the input be here. I just give one more input, call it, let's say, LOCHN, say IDX. Now here, like I said, we're introducing, say, LOCHN. So I set it to 0 because I always start with 0. Just like in the step change index, LO change index will also start with a 0. So that keeps the code quite nice and simple, and quite kind of homogeneous. So I say, okay, look, let me start a new variable called, let's say, mmm. I set it to say 0. Now I'm going to follow almost exactly this code. So I just go and copy this piece of code. I say, okay, let me check if my, um, if let's say the index has become equal to LOCHN, say LOCHN. So is this one of those index where the label offset is going to change? Well, if that is the case, well, let me first figure out the next label offset. So that will be next, I call it next LO. This will be a list which I read from the list of lists called label offset, and I read it at the index number MMM. Now, next time when this condition happens, I would like to read the next value. So I'll make this MMM equals to say MMM plus 1. Now I can actually remove these two. We don't need this anymore for this part. Now, once I have done this, obviously I must update the LOCHN. So just like here, so I just go in here and say, okay, let me find out where does the label offset change again. That is the value of LOCHN. I'm going to read that from this list LOCHN index. Again, I either find the next index in this list, or I just set this to 1000 if this is the last time the LO of the label offset is, let's say, being changed. So I just like earlier, I set this to 1000. This try and except makes the code robust so that the code does not crash. Now, having done all of this, I now need to make sure that my code, let's say, runs properly by changing this label offset to next LO. Because remember, now label offset is a list of lists that is being read out at, let's say, line number 30. So 0. I just need to say, well, look, the 0th value of this next LO is a label offset in the X direction, and let's say the first value, so next LO1 is the label offset on the Y direction. Now, having done this, my function is ready. But remember, in order to call this properly, now I must convert, the let's say the label offset itself into a list of lists. So I just make it say 030. That's all right. But it must be a list of list, and I give here, let's say, 0, just one element 0, because I do not in this case want to change the label offset. For now, I've commented out the Python line. Code, it's exactly like earlier. I get one line, every label is offset by 030, even though this is now a list of lists. But before I bring in the Python line, let's do a small, let's say I say, let's make it 0 and say minus 30. So I want that at, let's say, station number 5 onwards, at station number 5. So remember 0 1 2 3 4 5. At this point, I want the stations to go, let's say the stations to be labeled, let's say, up here. So I'm saying, okay, look, make the label offset 0 minus 30 so that the labels go up at station number 5. And, and after that, it's always, let's say, 0 minus 30. Now, when I run this piece of code, notice my labels have gone, let's say, on top. Now, this is okay, but we do need to fix it for the Python line. So let's just go and fix it right now. First thing first, remember my label offset itself has to become a list of lists. So I'm going to say, well, let me start with 40 0 for to initially. Later on, I want to make it say 0 and 40. So the labels go below. And where does this change? So this must be a list of lists. I'm going to say, well, make this change at station, let's say, so if of course, the first item is 0. And thereafter, I'm going to say, and thereafter, I'm going to say, look, 0, 1, 2, 3, 4 is where I want this to change, because these are fine. So at 4, I want to put these below here. So I'm going to say, well, my LOCHN index is 0, 4, and let's say 6 and then blue. And this is really all I need. Notice when I run this piece of code, it's pretty cool because first 4 stations were written on the right side. Now the next 3 stations starting on 4 are being written below. Now 040 seems a little too much. Maybe we can make it 0, say 30, just like for the scratch line. When I run this code, this looks nice. The network is kind of easy to. Now we may want to make one more change over here. We might say, okay, let me bring this WiByte a little bit closer to the station. Again, how do I do that? Well, remember, I need to basically specify one more LO offset, one more label offset. So I'm going to say, well, instead of 030, let me make it 0, let's say, 10, so that orange thing comes up. list of lists again, and this change must happen at, let's say, station number 4. So my LOCHN index for the scratch line becomes 0, 4, and 5, and I think that should look pretty cool. So when I run this piece of code, notice this orange color WiByte has gone up and everything else remains same. Now you can see that this has become very, very flexible and the logic is quite beautiful. I hope you found this interesting. In general, if you think this way of learning programming is fun, it makes you understand concepts better, well, look at our website because that is how we learn Python programming. Take care. Thank you so much. Bye bye.